let's start. So today we will look at working with strings in R. There's a lot to cover here. Look at this PDF. It's 162 slides long. Well, I guess only 82, but I guess, I don't know. I put enough pause breaks in it. So now there's like 162 things. But anyway, we'll get through some of this today, and then we'll finish it up on Friday. And even then, we might not get through everything. I don't know. There's a lot to cover here. A lot of you have started on your homework, which is great. And then you got this one task where you have to kind of parse out the manager's column with regular expressions. And that's what this today's lecture is all about. We're going to be introducing regular expressions. And so, so anyway, I introduce this and I say, a lot of other stuff deals with numeric data, which is great. And, you learn a lot about a lot of stuff, pretty much all of your other classes are designed to work with numeric data, right? 100B and, all of these other, the 100 series and the 101, well, 101A and 101B will all be kind of numeric. And then, but what do we do with text? Because text is often a thing that we have to deal with a lot, okay? And so there's all kinds of stuff that we're developing that deal with text. So we got textual data analysis, linguistic analysis, text mining, sentiment analysis, and natural language processing, and all of this stuff. And there's a whole bunch of stuff. There's a textbook that you can read if you have the time and interest in it, Tidy Text Mining. This one is, you can read the entire textbook for free in your browser, or you can spend money and get a paper copy as well. And, text-based analysis is a little bit beyond the scope of our course, but even to get started with text-based analysis, you'll need to get a good handle on regular expressions. Regular expressions is a way for us to kind of just process text and text-based data. And so let's see. So we're going to look at just some common stuff for string manipulation. And here is a bunch of resources that I think will be useful. So we've got the whoops, oh, that link is no longer any good. Okay, let's see if these links are still good. Okay, we have the regular expressions cheat sheet, which will be useful. There is handling strings in R, and this is another textbook that you can read in your browser. There is the chapter on strings in R for data science, okay, which is pretty good. And there is this vignette on string R, which is also great. Okay. These sites are also excellent for testing regular expressions. So if you wanted to get some practice testing out your regular expressions, you can do this. I really like this one, regexr, regexr, and you can type in your regular expression, and it's got just some sample text, and it will show you what gets matched with the regular expression, which is I highly recommend this very last one right there. Okay, so anyway, let's just talk about let's just get started. So anyway, we got characters, right? We got character data, string data, strings and characters. I kind of use these interchangeably. In Python, we call them strings. In R, it's characters. It's like the same thing, right? And basically, you put something in quotes, and R is going to recognize, okay, this is character. This is character data, right? So hello world, okay, type of character, boom, easy, okay. And then, because it's quotes, you can't put other quote. If you create it with using double quotes, then you can include single quotes. If you started off with single quotes, then you can put in double quotes. But if you try to do double quotes with double quotes, then this gets, it gets angry, right? And so if you want to include double quotes, then you can put in a backslash. The backslash here is going to escape the meaning of the quote, and it will become the literal quote character, double quote symbol, okay? Backslash, the top is pointed back. Regular slash, the top is pointed forward, okay? Empty characters is just this, okay? So when you call character, it's going to create a vector, character vector of some specified length, and the default value will be the empty character, which will just be kind of a opening quote and a closing quote, but no content inside. Okay, that would be an empty character string. Okay, now it's important to note that the empty character string is not the same as character 0, which is a character vector of length 0. Okay, putting the empty character string, okay, it would be identical to character 1, character string of length 1. Okay, character string of length 1 has one empty character string in there, right? It's got an opening quote and a closing quote, but nothing in between. So it's type character, and that counts as an element. So that would be character 1. It's not the same as character 0, 0 length character vector. Okay, so this is one of your most basic but important functions in Python for handling string data is the paste function, and that just kind of pastes elements in a vector together to create character vectors and character elements, right? So what it does is it takes whatever objects you feed it, converts them into character, and then it kind of pastes them together to form character strings. So so the basic syntax is just a bunch of stuff, any number of objects. The default separator is a space character, a single white space character, but you can change that to something else. And then collapse is the argument whether or not to separate the results, okay? There's another function called paste 0. Paste 0 behaves exactly the same way as paste, except the default character in paste 0 is the empty character, right? So by default, paste will put spaces in between them, and paste 0 will not. But other than that, these two things behave exactly the same. So here is some examples, right? I ate some, and then you can put in the mathematical value pi, and it was delicious, and there you go. All right, and now you can put that on a t-shirt. All right, here we've got, I don't know if you ever watched The Office, but we have Bears, Beets, and Battlestar Galactica, and we can put the separator as the comma space as our separator, and it will take these three things and paste them together. This is where collapsing and no collapsing and stuff make a difference. So here I have two objects. One is the character H. Another is a vector with characters A, E, and I. So this is a vector of length 3. And here my separator is going to be the empty character. All right, so this would be the equivalent to using paste 0. And so what it returns is a vector of length 3. This does it recycles the H and is going to paste the H with the A. It pastes the H with the E, and it pastes the H with the I. And so the result is a vector of length 3. Here I've got a vector of length 3, ABC, another vector of length 3, 1, 2, 3, and I'm going to paste these together, and it pastes them element-wise, okay? A1, B2, and C3. Here I've got a vector of length 1 and a vector of length 3, and then I specify collapse. So the default is not to collapse it. Collapse is null, but here I am collapsing it, okay? And so basically it recycles the A, and it's going to do A1, A2, A3, And instead of returning a vector of length 3, it's going to collapse that 3 and going to paste, connect them further and separating them using comma space. And so now the result is a character vector of length 1 with A1 comma space A2 comma space A3. This is the one single character element returned. Okay. Does that kind of make sense to do this? So what do you need to do to get A1, 2, 3? Well, you can't give it a vector of, you'd have to collapse the 1:3, or you'd have to collapse that into 1, 2, 3 first. So you'd have to do like a paste A with a paste of 1, 2, 3, paste 0, 1, 2, 3, and then it would put those two together. Okay, so the issue here is it's seeing 3 elements, and so it's going to do this, right? So here, let me just show you what it is that you want to do. So the question was, how do we get A1, 2, 3? Okay, so you'd have to kind of do a paste 0 on this. Okay, so you do paste 0, collapsing the result of paste 0, and then you can connect that to A. All right, we've got print, we got cat, and then we have format. All right, and I think everybody's familiar with print and cat. Format is if you want to print with special formatting. So there's also, by default, whenever you print characters, it's going to put quotes around it, right? So anytime you print characters in R, it puts quotes around it, but you can put in the option quote equals false, and it will not put characters around it. You can also do no quote, okay? No quote is kind of like print with quote equals false, although they are not exactly the same, in that when you call no quote, the result is what's known as a no quote class object, which will always kind of retain this this behavior. All right, cat, we've got cat, and you can take X, which right now says hello world and hello universe, and it will just kind of output it onto the screen. And right now we can say the separator is comma space, and it will do this. All right. The printing of cat, notice that when you do print or no quote, puts square bracket 1 square bracket to indicate that this is a vector of length starting with index position 1. And if we had multiple elements, you know, it'd kind of keep going, and if it started a second row, it'd probably be like square bracket 8 or something like that to indicate that that's the 8th element. Cat doesn't do any of that. Cat just kind of straight out puts onto the screen. Okay, no vector index, and cat returns an invisible null, meaning there's no kind of value being returned. If you tried to capture the output of cat or something somewhere, it just doesn't work. And then cat, another thing that's useful with cat is you can output it not to the screen, but to some kind of text file. And you can decide whether it's going to append or overwrite the existing text file with cat. And you got more options if you're dealing with like long strings and stuff like that. Format is allows us to kind of print things with to kind of format our stuff a little bit nicer. So we can specify a minimum width, which is going to kind of add padding to the text output, or we can trim the output. You can also justify it either left, center, or right. Okay, and center I think is spelled funny. And then as far as how does it get printed, as far as numbers go, you can specify the number of digits. N small specifies the minimum number of digits to the right of the decimal point to include. And you can use scientific notation or standard notation. So here is, let's do 1 divided by 1, 2, 3, 4, 5. And we're going to format it so digits is 2, and it outputs a bunch of a character vector, 1.00, 0.500, 0.33, 0.25, 0.20. Okay. We can use scientific equals true, and now it outputs this. Here is some character stuff. We're going to say width equals 10 and left justify. And so now each of these elements, each thing has a width of 10. Okay, so it pads spaces on here so that each thing has a width of 10. You can play around with the format function to see if you can ever get it to do what you want it to do. And sometimes it works and sometimes it's frustrating. Let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is D as in dog. D as in dog. All right, let's look at some basic basic string manipulation in R, right? So first we've got just a few, these are kind of base R functions, so you don't need any package here. Number of characters, make everything lowercase, uppercase. You've got this character translate function, which is a little bit strange. You can also extract substrings, or you can split a string into substrings. So number of characters tells you how many characters are in each thing. So hello world, hello universe, 5 characters, and these words, 8 in universe. Make everything lowercase, make everything uppercase. It's pretty straightforward. Okay, what is character translation? Okay, basically you come along and you say, so remember, Y is this vector, hello world, hello universe. And we're going to say, I want you to replace every instance of the capital H with a lowercase y. And so now we get yellow world, yellow universe, or something like that. Okay. And then you can also do this, and this goes element wise. And so I don't know if you were trying to pretend to be some hacker kid or something. You can say, I want to replace all instances of E with the number 3, instances of the L with the number 1, I with an exclamation point, and O with a 0. And now you get H3110, W0R1D, and something like that, but you can still kind of read what it is. Okay, that's character translation. That's I don't know when you're ever going to use that, but it could be useful in some situations. Okay, substring says, start at this character and then give me the next 9 characters. So as far as X being hello world, we can say start at the second character and, oh, I'm sorry, end at the 9th character. End at the 9th character, not give me 9 characters. Okay, we can say split on the space, and it gives me back a list, and the first element of the list is hello, a vector of length 2, hello and world. Okay, we can say split on the O, and hello world becomes hello hell space W and RLD. That. Okay. So far, so good. All right, let's introduce package stringr. This is part of the tidyverse, and you can load it up using library stringr. You can just call library tidyverse, and this will load stringr into it, the function into R. And I think stringr is great. Stringr is great as far as manipulating and working with character data and dealing with strings. So and it says the functions are intended to make R string functions consistent, simpler, and easier to use. And I agree with all of these statements. Okay. All functions deal with missing values and 0 length characters appropriately. No kind of issues there. All right. Functions and argument names are consistent. Okay, and the output matches the input data structure. Okay. All right, sorry. We have question. Could we have used month convert using chart R? No. The homework problem month convert would not have worked because character translation does element-wise character translation. Okay. And then another question. What if you want to replace the specific phrase ELIO with something else instead of the individual letters? Yeah, that's where we use functions from string R. Okay, so this character translation business, this is like a very limited use case scenario. Okay, because it just says element wise things, right? Character with character. You can't do like entire words or things like that. It's not a find and replace where it's like find the word John and replace it with the name Jack or something. But it's character. Replace E with 3, replace L with 1, and it's in my opinion, limited usage. Okay, so the questions that you're asking, character translation is not the solution there. Oh, what happened here? This was supposed to be a list. Okay, I don't know. All right, we've got string concatenation, similar to paste, string length, which will do the number of characters, similar to number of characters. String sub will extract substrings. String duplicate will duplicate strings. String trim will remove leading and trailing white space. String pad will pad a string. String wrap will wrap a string. And string trim trims a string. So these are kind of your basic functions. So here are just a couple differences. So we have paste, and string C will be concatenate. And what this does is it automatically removes anything that's null or character 0. So if you gave null or character 0 into paste, it's going to put those two together, or insert those in here. So this is just kind of like weird things that you forget about, and then when you use it, you go, darn it, I don't want that. Okay, so string concatenate handles these things and cleans it up, which is probably what you want. Okay, the default separator for string C is going to be the empty string. Okay, whereas for paste, it's so I guess string character is more like paste 0, but it handles the null and character 0 things as such. Okay, string length works with factors, whereas number of characters does not. So if you called n characters on a factor, it says that's not going to work, right? Because a factor is internally stored as an integer vector, and this doesn't like that. Okay, whereas string length will say, oh, I know what you're talking about. This is a factor. Internally, it's stored as integers, but let's look at the factor levels and give it appropriately, right? So January has 7 letters, February has 8, April, January, February, March, April, May, June, July, August, September, October, November, December. September, that's the longest named month. Okay, and now we get to the exciting part with regular expressions. So one thing that we really want to do is pattern matching, okay? Which is finding a pattern in the text and identifying it, okay? So formally, a regular expression is a pattern that's going to describe a set of strings, okay? So regular expressions are kind of a formal language in the sense that the symbols have a defined set of rules to specify the desired patterns. And honestly, the best way to learn the syntax and become fluent with regular expressions is just to kind of practice it, all right? So there's only so much I can give you in all of these slides. There's a lot of slides. There's only so much that this can do, and really it's just going to have to come from practice and playing around. Here's some applications of regular expressions, right? Test if a phone number has the correct number of digits. Test if a date follows a specific format. Test if an email is valid, okay? Or test if a password has a certain number of characters or numbers. You can search for, alternative spellings of words, right? Gray or gray with an A or E. You can find all occurrences of, say, something, somebody with multiple names or aliases, William, Will, Bill, W, or William, or something like that. Count the number of times a document, in a document that the word analysis is immediately preceded or followed by another word, okay? Convert common delimited files into tamp delimiter, find duplicate words. Okay, so these are all kinds of different things. So we have these functions: string detect, string locate, string extract, string match, and string split. All of these are in the form of, we want to apply this to a certain string, and then here's the pattern that we are searching for, which lends itself very nicely to piping, right? So if you have a string, you can pipe the string into string detect. It's automatically going to go into as the first argument, and then you just apply the pattern. But you can also just do string detect the string comma pattern. String detect is going to return a logical vector, true or false. String locate will return an integer, okay? The first position, all right? So where is this pattern located, okay? String extract will return characters. It's going to extract the text that corresponds to the first match. String match will extract any kind of capture groups, and we'll explain what a capture group is. And string split will take a string and will return a list of character vectors. There's also, all of these things have underscore all variant. So you have string detect all, string locate all, string extract all, string match all, and things like that. And that will happen if these work whenever you have more than one instance, right? So a lot of these things say locate the first position or extract the text corresponding to a first match. And if you want to say, I want to extract all the locations, right? So this, we might find multiple matches, then you would use the underscore all. Okay, let's start with some example patterns and things like that. Okay, the most simple pattern to match is just literal characters. Okay, and it just says I need an exact match of these exact characters. So a literal character match is one in which a given character, such as the letter capital R, matches the letter capital R. This type is the most basic type, and it's just matching plain text. And I think we're familiar with this because, I don't know, like in Microsoft Word, you can run like find, and it will find basically literal matches there, okay? All the letters and digits are literal characters, and they match themselves. So for example, I have the string I love stats, and we are looking for the pattern STAT. And string locate will give me the numeric location of this, and it's going to say it starts at character 8 and ends at character 11, right here. 8, 9, 10, 11, right? So it starts here and ends there, and it finds the match there. Okay. If I have I love capital stats, and I say search for this pattern, STAT, lowercase STAT, then it says I can't find it, okay? Because it's looking for this exact thing, and it's case sensitive, so it doesn't work here. Here, string locate returns only the first occurrence of a match. To find all matches, you can use string locate all. So here is the string. It's going to be love stats. I love statistics, comma, so I am a stats major, period. And so we have, we're going to search for STAT, and we can find it right here, and we can find it right here. when you do string locate, it's going to find it from here to here, the 8th character, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Starts at the 8th, ends at the 11th. String locate all, what's it going to do? It finds this one from 8 to 11, and it keeps searching, and it also finds it over here, the 30th to the 33rd character. And that's what we have. Okay. So if you know you have multiple instances of whatever pattern it is you're looking for, and right now our pattern is just the literal characters STAT, you can use string locate all to find all of them. Let me go ahead and give you your second view quiz answer. Second view quiz answer is B. B as in bear. B as in bear. B as in bear. So string locate will return a matrix. Okay. And string locate all will return a list whose elements are matrices. So technically, this thing right here where I have love stats, this is a vector of length 1. I could provide it a vector of length 3. So let me just show you what's going to happen. All right, so right now I've got love stats and whoops. Okay. Oh, come on, don't do that. All right. So okay, so this works. Now let's say I've got I'm going to call this long vector, and this would be this, and I'll just put in some extra gibberish here. Okay. Oh, so we'll do it for long vector now. Okay. So long vector, because I have 2 elements in here, it's going to return a vector, a matrix with 2 rows. Okay. If I do string locate all on the long vector, it's going to return a list with the elements. Okay. So this is it gives me a list. The first one is a matrix showing it found it at 8 and 11 and 30 and 33. And then for the second vector, or the second element in the vector, it gives me back another list with another matrix. And it says it's at the 10th through 13th character and the 33rd through 36th character. So, so we have that. Okay. It can only do one pattern at a time. It can only do one pattern at a time. So if you have different patterns, you're going to have to run different commands. Okay, we can only just do one pattern at a time, but you can make your patterns very complicated is the thing. Okay, you can make your pattern very complicated to look for like different words and things like that. And we'll talk about that. But it can only do one pattern, but you can make your pattern complicated to match multiple things. So do these string functions only take character vectors of length 1, or can they be longer vectors? Yes. So I think I just demonstrated that. So it takes a character vector. Right now, for the examples in the class, I'm using a character vector of length 1. But again, you can do a character vector so here's a character vector of length 2, and it operates, and what it returns is a little bit different, right? Okay, not all characters match themselves. And so what we have that aren't literal characters are what we call meta characters. And the power of regular expressions come from the ability to use these special meta characters that modify and really make the pattern matching very, very powerful. And so the meta characters that we use are these. These are the meta characters. Okay. And so we've got the dot. I don't know what this is. The caret, the $sign, the asterisk, the plus, the question mark, curly braces, square braces, curved braces or parentheses, and then the slash and the vertical bar. Okay, so the dot or the period is the wild meta character, the wild card. This meta character is used to match any single character except a new line. So for example, I've got this character string, character vector not, and I've got not, note, not, KNOT, and nut, NUT. String detect, we're gonna search through this. So remember, detect returns a logical vector. Does it detect this pattern? And it's gonna look for n.t, any character in here. And it's gonna return true, 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 because it finds n wildcard t, n wildcard t, n wildcard t, n wildcard t. That is fine. Okay. What about NO wildcard? NO wildcard, this will detect it here because we've got NO something, NO something, NO something. We don't have an NO, we have an NU. So we get true, 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 and false. Okay. Oh, I don't know what's wrong with my formatting here. Okay, I got fives. I got 5.00, 5100, 5-00, and 5 \00. And the question is, what will string detect fives? This, okay, we got that is fives, and it's asking what is string detect fives? The pattern is 5.00. What is this going to match? It's going to match all of them, right? It's going to match all of them because it's just asking for the wild card. Is it 5 something 00? And these are all 5 something 00. So that's going to return true for all of them. And indeed, when I run that, I get true, 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 true. All right. If you want, okay, meta characters aren't matched literally directly as literal characters. If you do want the literal match, you have to escape the meta character by using a backslash in front of the meta character. Okay, but in R, the backslash itself is a meta character for normal strings. So we need to do a double backslash. So for example, we can say, hey, do we have the opening square bracket here inside this string? And R says, you can't do this. You can't do this, right? Because I'm treating this as this. So if we want to match the literal opening square bracket in this string, we have to do backslash, backslash, square bracket. Okay, backslash, backslash, opening square bracket, right? So what do you want to do if you detect with the period? You have to do backslash, backslash, dot, period. Okay, so if we did this, this is going to return true for everything. If we want to match exactly 5.00, we would have to do this pattern, 5 backslash, backslash, dot, 00. Okay, and we're going to get a match here, and then we're not going to get a match on any of these because these don't match the literal 5 literal dot, which is what we are saying, 5 literal dot 00. And that's that only matches this. Square brackets indicate a character set. Will match any one of the characters that are inside the character set. A character set will match only one character, and the order of the characters inside the set does not matter. So for example, let's say we have the character set defined by the square brackets A, E, I, O, U, which will match any one lowercase vowel, only kind of the traditional vowels, not Y, I guess, which is entirely a vowel as well, but we'll just do A, E, I, O, U. Okay, and so here I've got a vector of a bunch of things. I've got pan, pen, pin, P0N, P.N, PAUN, PWN3D, and happiness. Okay, so which of these will match P character set one of A, E, I, O, U, N? So when we run this, this is a match, right? PAN, that's a match. PEN, that's a match. PIN, that's a match. P0n, this is false. This is 0 is not one of these. P dot n, also false, okay? Because here the wild card of a dot applies only inside the pattern, not here. This is a literal dot over here. PAUN is not going to match. Even though A and U are both in here, this character set matches only one character. This is a W, so it's not going to match here. And this will return true because we find a match with PIN over here. So as far as string detect, we got true, 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 false here, false here, false here, false here, and true over here. Is that okay? As far as how this works. So it matches any one of these characters, but only one. So it's not going to match this. These slides are fairly dense. So as you review them, make sure you understand kind of each of these things. So if a set contains dots, does it match everything? Well, okay. There are special rules that apply for when you put characters inside a thing, and I'll get to that in a moment here, okay? So let's say you wanted to define the character set where we're going to look for all capital letters in English. So A, B, C, D, E, F, G, all through Z, okay? This is like a pain in the butt to write, okay? So we have the dash, and we can put a dash, and that's going to create a range of characters. So we can do A through Q, and that will be lowercase letters A through Q, capital A through Q, and that will be basically a character set defined as that, okay? You can do A through Z, and that will be the 52 ASCII letters, right? So regular expressions are very ASCII centric, which is, you know, great for English, US English, but you know, foreign languages, you know, a little bit trickier. Okay, all digits from 0 to 7. Okay, question: could you do double digits in this range? No. Okay, these are all single character things. Now, if you want 2 characters, we can write a pattern that will do 2 characters, but I'll show you how to do that. Okay. All right. So character ranges are useful. So let's say we've got this. Okay. I've got 1, 2, 3, 8 little ABC, big capital ABC, colon dash closing curve brace, AB12A, A8908AB. Okay, how can we say we want to match 3 adjacent digits, right? So I think this is kind of related to your question of double digits. Now I'm asking for triple digits. How do we do this? Well, we can define a pattern match with this, right? Each character set matches just one character. So we're just going to do 0-9 square bracket, 0-9 square bracket, 0-9 square bracket. And this will match one instance of 0 through 9, one instance of 0 through 9, one instance of 0 through 9. And because they're all next to each other, this has to be 3 numeric digits in a row. All right. So we're going to get a match here at 1, 2, 3. No match, no match, no match, right? So this is true, false, false, false. This is still false because we have AB12A. There's only 2 characters, 1, 2 here. And this will be a match because it reads, as it's reading left to right, 890 will match as a match to this, 3 digits in a row. Okay, there's a 4th digit, but it doesn't care. It just says, hey, you asked for 3 digits. I found 3 digits in a row. So it's going to give us 3. Okay. Similarly, if we wanted to find 3 lowercase letters, we can write A through Z, A through Z, A through Z in square brackets like this. And it would match this, and that would be the only match. It would be false for everything else, and it would be true for this one, the second element there. Is that okay? A common situation that we want to do is negative character sets, which says I don't want something like this. So this type of matching can be done using a negative character set. And so we can use a caret to create a negative character set, okay? And this all, you have to put the caret in the first position inside the square brackets, inside the character set, and that's going to mean negation. So if you say square bracket caret A-E-I-O-U, it means match any character except these, A-E-I-O-U. Okay, I don't want A-E-I-O-U. Okay. And the character has more than one meaning depending on where it appears. So it has to appear, if it appears at the start, at the front of a single square bracket, then it's negation. So for example, the pattern here will match any character that is not an uppercase letter. Okay, this will be anything that's not an uppercase letter. So it's going to match true for everything except this. Okay, true for everything except the capital A. If the character is not, the caret is not in the first position, then it becomes the literal character, the literal caret character. So if the this will become a literal caret. So now this will match any capital letter A through Z or the literal caret character. So this is going to return false for everything. It will return true for this, false for these, and true for this. So when you don't put the caret, if you don't put the caret in the beginning, it becomes the literal caret. How would we write a pattern that Matt says, I want to match everything except the caret? Anything except the caret. Okay, so you can do caret, say anything but, this is negation. And then you can do backslash the caret, which will be anything except the caret. You can escape the caret and it will do that. And this will be true for everything except the literal character, caret character. And that will work there. Okay, when you put a dot inside the character set, this will become the literal character. Okay, most meta characters inside a character set are already escaped, so you don't actually need to use double backslashes. All right, and so here this will match any vowel, A-E-I-O-U, or the literal dot here. So now we got a match for pen, pan, pen, and pin. We don't have a match for P0N. We do have a match for P.N. We don't have a match for this, and we don't have a match for this. Okay, the dot inside this character set now represents the literal dot character rather than the wildcard character. Okay. Not all meta characters become literal characters, and the exceptions are the dash and the caret when it's at the front, and the backslash. What if you did caret, caret? Yeah, so that would actually work. So for back here, you could actually just do caret, caret. You don't actually need these backslashes. It's true. You could just do square bracket, caret, caret. You don't actually need these backslashes because of this rule. Oh, it's a lot. It's a lot. Okay. Why don't we end here? Okay, we'll end here and we'll come back on Friday and we'll really get into this with character classes, right? So these are basically like shortcuts. So instead of having to write single square bracket 0-9, because this is such a common occurrence, we can write /d. Oh, I forgot to give you your third view quiz answer. Third view quiz answer is A. I was gonna be like capital A because I'm so used to reading all these characters literally, but it's A for your third view quiz answer. And that will be it for today. You can take a preview at the remaining slides, and you can start playing around with this. Again, I recommend that website regexer, which was linked in the beginning of these slides. But yeah, we'll finish out the slide deck on Friday. So we'll see you guys then. Have a good day.